All right, so now let's talk about standard deviation, z-score, and z-table. All right, recap: variability, sum of square, and variance. Right. Um, so five gullible scores of Aries, and the mean is 41. And remember this. See the distance between 32 and 41 is -9, right? And the second score 50 and 41 is 9, and so on and so forth. So we square each score, right? And then add them up. That's 164, which is called, you're right, sum of squares. Now, sum of square need to be divided by n-1, right? Which is degrees of freedom. That is 41, and this is called variance. Okay. Now, this is the formula for the variance. All right. And as we said, we don't like a square, right? So we like to take the square root. So this is called standard deviation, right? In our case, the square root of 41 is 6.4. That's the standard deviation. And the formula is this, just so you know. Okay, this is a square root of the whole thing. All right. Another thing is this: why do we need to know about standard deviation? All right, it's really useful. Okay, so for example, as we know, people's IQ scores, the mean is 100, about 100, and the standard deviation is 15. This is a standardized score. All right, so um, suppose you collect a lot of people's data. Let's say 10,000 people. How about that? You ask about their IQ scores, right? And then you do a histogram of those scores. We have a reason to believe it will be pretty much normally distributed. So this is the IQ scores, right? You see, this is extremely low scores, 55, and then this is extremely high scores, 145. Not a lot of people are in the extreme end. Most of the people are in the middle, the average, 100, right? Normal distribution here. Now, what's very interesting is this. Statisticians tells us, you see, this is one standard deviation. This is a score mean 100, right? And this is 115. This is one standard deviation because standard deviation is 15. This area, according to statisticians, is about 34%. That means 34% of the people relative to the whole population, their scores are between 100 and 115. Same as this area, one standard deviation below the mean. That's between 85 and 100. That's another 34%. Right? Now, if we want to go beyond one standard deviation, now there's two standard deviation. The scores are between 115 and 130. Now, there's about 13.5% of people relative to the whole population. And here, between 70 and 85, there's 13.5%. Right? So, in other words, about 68% of people fall in this range within 15 points of 100, between 85 and 115. Now, if we extend to two standard deviation, between 70 and 130, that's about 95% of people. That means, 13.5 plus 34 plus 34 plus 13.5, this area. Okay. Now, less than 2% of people fall in this range, below 70 or are higher than 130, right? Now, this is interesting enough for us to apply to a real life case. So, for example, suppose Mark is me, right? And my IQ is 70. Okay, so how do I compare to other people? Now, first, let's look for 70. What is a 70? Oh, okay, it's right here. Okay. Now, how many standard deviation is 70 away from the mean. Let's calculate that. If that's 85, that's 1 standard deviation. And 85 to 70, that's 2 standard deviation. So this is 2 standard deviation below the mean. So now the question is how many people do better than Mark, right? All we need to do is add up all this percentage together, right? Now you might want to, add those numbers together, but we don't have to because this half is 50%. Don't you think so, right? So all we need to do is 50% plus 35 plus 13.5, right? So that is 84 plus 13.5. That's about 97, right? Something like that. Yeah. That means 97% of people do better than Mark. All right. I hope my IQ score isn't really that low, but it probably is a bit closer than I want to believe. Anyway, so in other words, if we know how many standard deviation a score is away from the mean, we know where this score stands compared to other people, right? So another example, suppose Mark's IQ in fact is not 70, it's even lower. So it's a 64. Now where am I, right? The first thing we want to do is to know the distance between 64 and the mean, which is 100. So 100 minus 64, or maybe you will say 64 minus 100. So it will be negative 36. Okay, and then how many standard deviations is this distance? 36 divided by 15, which is the standard deviation, right, is 2.4. That means Mark's scores is 2.4 standard deviations below the mean. Where is it? So this is the mean, right? So this is 1 standard deviation, then 2 standard deviation, and then 2.4. I guess it's about right here. You see, right? Now, right here, this score, how many people perform better? Have a higher IQ score than Mark? All we need to do is 50 plus 34, that's 84, and then plus a 13.5, right? That's about 97.5%, whatever, right? But we have some extra, 0.4. I guess we can eyeballing, right? Eyeballing, let's just say maybe 100, another 1%. So it's about 98.5%, maybe. So that's 98.5% of people do better than Mark, right? Eyeballing probably is not really accurate, really precise, right? Luckily, statisticians help us with this problem. They make this table called Z table.